Hi everyone. Today I will present important concept in C++, including pointers, arrays, dynamic memory allocation, binding, polymorphism, and virtual functions. These concepts are fundamentals for efficient memory management and object-oriented programming. Let us begin with pointers. A pointer is a special variable that stores the memory address of another variable. Pointers play a key role in dynamic memory allocation and efficient data manipulations. They provide direct access to memory locations, improving performance, and understanding pointers is essential for advanced C++ programming. See here, pointer declaration initialization. The pointers are declared using the symbol and initialized in the address of variables. The address of operator represented by embarrassed is used to obtain memory addresses. Proper installations is important because utilized pointers may lead to program addresses. Differencing allows you to access the value stored at the pointer address. See here, can you give some syntax then declare initialization and differences. See next slide, pointer to class object. See here, pointer to class object of this pointer. In C++, pointer can also point to object of a class. The arrow operator is used to access object members through pointer. Another important concept is this pointer, which refers to the current object involving a member functions. It helps between local variables and object attributes. The next slide, pointers to base and derived class. A base class pointer can point to an object of a derived class. This feature is the foundation of runtime polymorphism in C++. Through virtual functions, the appreciate derived class method is called during execution. This increases flexibility and support dynamic behavior in object-oriented applications. Next slide, arrays of classes. An array is called calculation of elements stored in contiguous memory locations. Array allow efficient storage and retrieval of multiple values using indexes. In C++, arrays can also store object of a class. Each object in the array automatically created and managed by the program. Next, memory model and dynamic allocation. C++ mainly uses two memory regions. The one is the regions heap. The stack stores local variables and manage memory automatically. The heap provides dynamic memory allocation during runtime. Dynamic allocation offers the flexibility but requires carefully memory management to avoid errors. Next, the new and the delete operators. What is the meaning of new and delete operators? New means the new operator allocate memory dynamically on the heap of returns a pointer that memory. Delete operator releases the allocated memory when it is no longer needed. Every allocations with the new should have a corresponding delete statement. Proper use of this operator prevents memory leaks and improves program efficiency. Next, dynamically object and binding. Dynamic objects are created during the runtime using the new operator. Their lifetime is controlled by the program rather than program scope. Binding refers to the connecting a function's call with its function's definitions. Early binding occurs the compile time, while late binding occurs at runtime and support polymorphism. Next, polymorphism and virtual functions. The polymorphism allows a single interface to represent multiple form and behaviors. Compile time polymorphism is achieved through the functions and operator overloading. Runtime polymorphism is achieved through the virtual functions and inheritance. Virtual functions enable dynamic binding, making applications more flexible, scalable, and maintainable. See here, uh, these sessions to conclude pointers and arrays provide efficient memory handling while dynamic allocation offers flexibility during runtime. Binding, polymorphism, and virtual function enable dynamic and reusable software design. Together, these concepts from the backbone of advanced C++ object-oriented programming. Thank you for your attention.